like to talk to you a little bit about the API design we went through at Tradeshift and the practices that we kind of learned and kind of applied while becoming where we are today. A little bit about Tradeshift. So we are a business transaction platform for predominantly small businesses, but all the way up to enterprise as well. That we want to allow to exchange the documents that make part of transactions that business-to-business interactions make use of, which starts with invoicing, electronic invoicing that is. But we want to go way beyond that and, for example, allow small suppliers to reach big buyers while offering their goods and people to find each other, to find new business opportunities as well. And we started around electronic invoicing, but we really only used that as the driver to become sort of a viral approach into business-to-business communication. As you can imagine, if I'm invoicing you, you must be invoicing somebody else to get your money, and that's sort of the driver that we hope to grow the network of companies on which Tradeshift is based. Right now, we hope this year to grow to about 500,000. We're at 100,000 now, and what we found really is that by focusing especially on the small businesses, by making the platform extremely accessible, extremely easy to use for people who just run a one-man shop and want some help in their invoicing while still being able to have access to everything and be legally compliant. By getting those people on board, it turns out that is exactly what, until now, the electronic invoicing world was not able to do. What you typically found was the big enterprises implemented electronic invoicing because it would save them money, and then they actually used it as a tool to get all their suppliers to use specifically that format and have a completely custom integration for them. Now what we're trying to do is open that up, use as many open standards to allow everybody who wants to extend what we built and to use what we put out there to make their own integrations. And we see actually a lot of small companies doing that. Most specifically, what we've launched over the past year is an apps concept that you can somewhat compare to what Facebook is doing, except that our apps extend all the way to our backend as well. So you can extend our user interface with stuff here and there, where you can, say, put a map on an invoice if you happen to be in the transporting business. But you can also write something that runs all the way on our backend when somebody receives an invoice on a particular account to have some custom code running or call to your integration to notify it of some actions that it needs to take. And people are using it. What we found while setting up our own API, in a more general sense, what are things that you have to, what are things that you run into as you're building up a cloud service like that? One thing we found is that there isn't really any such thing as the way the world is. You think one day, oh, this is how enterprises want to do their invoices, until you sign up customer number 2 and you find out it's all different. We're now in a place where we have about 100 developers and releasing almost every other day some new features to production, which actually might include API changes. And as you can imagine, it's a challenge to keep those things in line and make sure that the things keep consistent and keep working. Secondly, the data that people put into our platform, for the average business, your invoicing and your financial records are a little bit more important than the pictures you put on Instagram. And people are concerned about two things. One is what are you doing to my data? Where is all my financial data going? Where are you storing that? Who has access to it? How do you make sure nobody else has access to it? But maybe even more importantly, something people don't think about as they put presentations on Google Docs, as I've done, which is how can I get my data out? What if I want to go to a different invoicing provider or a different network, or move my stuff to somewhere else? Is it possible to get these things out? And I'm not sure if it is intentionally or just by accident, but a lot of cloud providers don't really have the button which says, export all my data, please get me the hell out of here because I don't like it anymore. Now we don't have that button, but we do have the API that allows you to get all your data in formats that are described by open standards. Thirdly, and talking about those open standards, where I guess I have to define open today. Open being that more than one person agrees on what a certain thing should look like. I guess the stuff that we're putting out there, we're not that special. I mean, invoices have been around long before Tradeshift. HTTP communication has been around long before Tradeshift. REST has been around. So we try and use those things as deeply as we can, not just because it saves us time, but also because it allows people to reuse knowledge that they might already have. If you say, hey, I got a REST service and this is my URL, people are going to find out, okay, so if I want to put a document there, I call put, and I want to read it again, I use get. If you were to use, say, SOAP for that, you'd have to completely say, okay, you have to use these methods and other things just to interact with that. Yeah, and thirdly, it helps you to write document. It saves when it comes around to documenting people and documenting your services and providing support for people. If you can just say, we use this particular standard for invoicing, and you please go over there and have a look at how you're supposed to use that. It just saves a lot of time because you don't have to be involved in helping people to find out what that format looks like. And the format that we use for internally, at least for invoices, is called Universal Business Language, which I had no idea was around. But then again, I don't invoice many people before I started to work for Tradeshift. It's a standard based in XML and in XSD, so you can find it on the web, which defines pretty much everything, mostly financially, that you can find in everyday business transactions, from a purchase order to an invoice to a credit note, which is a cancellation of an invoice, and all the weirdo things that people do around that. The advantage of having such a standard is that you don't have to think about, okay, where am I going to put the financial stuff and the totals, and what about taxes, and I heard this country does something weird with taxes, is going to fit my model, and then, as you discover that, yes, there are weird countries that have weird rules, you're going to be changing that all along. So, people sat together at some point and have already fixed that for most of the weirdo cases that you find out there, and it's great to be able to use that. It's designed by Oasis, one of the standard committees that is widely regarded as the international way to do these things. And interesting to know is that it's actually chaired by the same guy who pushed very hard for XML when it first came around, and actually for a very similar reason. John Bosak is his name. When XML came around, he was really a driver saying, well, we have to have this extensible way of describing interactions between systems, because that allows small parties to easily define a contract for what they're doing, and everybody recognizing that and working with the definitions that there are. I mean, before that time, there wasn't really a way to describe these kind of interactions on the web. And as XML grew into more adoption, he actually wanted to do the same thing for businesses, where before UBL was around, the way that you could do electronic invoicing was you could use one business network, one provider that had their specific formats, and then maybe you could invoice one or two enterprises, but that's it. By having a standard, if you subscribe to UBL through the networks that support that, and it's not just Tradeshift. I mean, the Danish standard, and there's a European network called Peppel. They're all based off of UBL. It's really being used right now. You have to use UBL, for instance, to invoice the Danish government. By using that standard, you can be sure that your invoices will be accepted in the networks that also follow that. So UBL defines some types of documents, but Tradeshift is more than just documents, right? We have a network aspect that says, well, I'm on Tradeshift, I got my company, and I regularly deal with these people and these companies. I'm also interested in those over there. They might be potential customers. That's also information, and obviously UBL doesn't define that. So we do have our own formats, but since UBL is based on, actually I should go back to this slide. Since UBL is based on a particular set of components defined for things like address formats, contacts to people, email addresses, things like that. By reusing those, at the very least, we can make sure that the way that parties are represented on Tradeshift and the way that addressing information is handled is the same all the way throughout the platform. So even if there is no UBL document for something, we might at least be able to use the UBL types to represent the things that we want to create. UBL is not the only format that we support, but everything in Tradeshift internally is handled on that, and actually that shows on the REST interface that I'll get to in a minute. So exposing that kind of functionality on an API towards these hundreds of thousands of mostly small companies, we found out while growing, I guess, past the 10,000 mark or so, that it doesn't really work to just have an API and somewhat write about it, because then everybody who is sort of halfway into Visual Basic or whatever, they'll want to try that out and work with it. And the first thing they'll do is stumble on something and then contact your support department, which gets more and more overloaded. So we found out that in order to build an API like this, and you've heard it before today, and it can't be repeated enough, make sure that people can find what they need, make sure that they can use it, that your documentation is in place, that you point to the standards that you're using where appropriate, and allow people to go through the whole process themselves. And actually for Tradeshift, maybe the case that people use the API mostly for their own company is kind of a more special case, because most of our integrators or most of the people that use the API are actually not third-party service developers that want to offer their service on top of Tradeshift to a lot of other customers. They are just the people owning a shop, and they want to have their Word-created invoices or something else automatically transferred onto Tradeshift as part of their normal business process. We define our API very much in a REST-based approach. Specifically, the URL-based mapping of resources is something we think about a lot, and I'll come back to that, because that really has helped us to maintain compatibility by picking the location identifiers for resources in such a way that as we come back and add stuff, that it still operates with previous clients. Which brings us to the next point. You want to deprecate as little as possible. If you have a platform where you're releasing every other day, you're adding stuff to the API, people that are already working with it, they don't want to get notified every time that changes, and you also don't want to version your API every day, saying, if you were using it on November 15th, it looks like this, but then the day later, please use this other WSDL over here or something else what it looks like today. If people use the API and they read some documentation, they sort of expect that it's still working like that. And we try to do that as much as possible. And luckily, we have not had to make breaking changes since we started having some traction on our public API. I can't really say if that's just because we're so good at it or because our API is so limited that the changes didn't really shine through, but it has been very effective. The way that we extend the API is obviously the only thing you can do, which is just add fields or add resources. But you have to have technologies that actually support that. I'm not sure how many of you are familiar with the intricacies of XSDs, but technically, if you write an XSD for a particular XML format, as soon as you have the XSD and you don't do anything special, it actually disallows adding other fields in that. Because if there are other tags in there, they're not according to the XSD, and if it is validated, then the validator should not accept it. Now, there are ways around that, of course, various ways within the XSD, and you can tell your parser to ignore the fields that it doesn't want. But it's sort of an extra step that sometimes you are unaware of, and some people are actually unable to do that. They have some big-ass ESB, and the architect said, you must validate your XML that comes in, and maybe they don't have a choice. So we do help integrators with XSDs, but generally we try to stay away from them and just describe the API in terms of examples, just to help the expectation management that we might be adding fields at any point. Of course, the JSON part of the world is used to that, but we do deal with more conventional or more older integration patterns where a bit more contracts are expected. One other thing we learned, especially as we grew, I mean, we were not always 100 developers. We're only 30 developers only a year ago. That is that not everybody has been designing REST APIs for 5 years. A lot of people have never heard of it, and some other people have heard of it, think they get it, and then just write post calls everywhere like it were soap. So you have to kind of be careful when you're introducing new APIs, because once you put it out there, and especially if your documentation and everything is launched right along with it, you're kind of stuck with it because people might be using it. They think, hey, I like this. It looks a little weird, but I can use it to create this report or get something out of my financial records. So you want to have a process in place to help and control that. But I'd say if I have to summarize it, is really try and minimize on inventing your own stuff as much as possible. Look around for the standards that there are for writing these resources and reuse them wherever you can. To look a little bit at what API design can look like practically, I'd like to look at a couple of examples of APIs. The oldest one I can remember is this. Not sure it's familiar to anybody here. Maybe it's too old, but at least one person. This is MS-DOS. It stands for operating system, something with a disk. This is how computers used to function, how you used to program them. It's called assembly language, and there were reusable stuff that you could call by saying, well, in this register here, I put this stuff, and then that stuff over here, and there's a limited amount of these, and then if I call function number 21, it will go and open a file for me. And then function number 21, if you set this guy to 3F, it'll actually read from that file. You have to know all of that, and I'm sure it's written down somewhere. But as you can imagine, there's a lot of stuff you can do wrong. And I kind of try to mark in red the stuff that you really have to know about this service that cannot be reused for any other service that you might be using. Let's look at another example and see if the red stuff becomes a little less. So I heard a lot about SOAP. I wanted to know what that was about, so I started searching for what I thought would be a simple service, like put something online like Dropbox. Dropbox doesn't have a SOAP API. I found a thing called filesanywhere.com. I have a SOAP API for putting files online. I figured, well, great. And I try and find the documentation. It's a 610-page PDF about putting files online. And they have a SOAP message here to upload a file with check-in. I don't know what a check-in is, but you can put your file here. And yeah, there's a lot of crux around it. But for those of you who know SOAP, all this jazz is just the way SOAP does things. So arguably, you can reuse this for your other service. But you still have to know the URL there and the namespace of your element, the name of the element, the name of these guys. And then they have some token, which I guess has something to do with authorization, so they didn't bother to use the SOAP standards for that. So, but you can use it, but there's a lot of extra stuff. Another way to put files online, you might have heard of it, is Amazon S3. They chose a different approach. They used HTTP. HTTP is a protocol that can be used to get stuff from the internet. But you can also put stuff, and you know the story. What's in here is all standard HTTP. Because HTTP handles with URLs, which are remarkably like files. So you just put here what you would like to store. Then this is just part of the protocol. The host that it gets sent to happens to be the Amazon bucket that actually gets to store the file. And the only thing they did themselves is this authorization part, which is a signature on the actual request of the file that you're storing. OAuth wasn't really around by the time they designed that, I guess. Otherwise, that could have been standard as well. I hope this makes clear a little bit that you really want to try and pick the service metaphor that fits best for what you're trying to put out as far as your API goes. So going into REST and into resource orientation, I wanted to find a metaphor for the way that you, at least in my perspective, ought to design REST resources. And I've used Unix a lot, Linux and other systems. I'm not sure if you guys have, but there's this thing about Unix. I had no idea it was Doug McIlroy that said it, but about small Unix programs that they're supposed to be, very good at one thing, and that you're supposed to combine them yourself to do bigger things. And it's kind of a nice way to think about programs. So you're one program for a small task, but it's very good at that, like text extraction or counting words or formatting C code. And you put them together to build something bigger. And at least in my vision, that's how REST resources ought to be designed. That you look at what does my business actually work with. In case of Tradeshift, we work a lot with documents. We have a network where your contacts sit, and the documents can be dispatched to those contacts. So we have those three concepts. So I would design my URLs around that the entity locations where I put these things. And that's sort of what my URLs namespace would look like. Because I know that years down the road, I'm pretty sure Tradeshift will still have documents, they'll still be a network, and we'll still be dispatching them in some way. Maybe what you get back will look a little different, maybe we'll have versioned something, but at least generally it will still look like that. So that's on the namespace side of things. Now, how do you interact with that namespace? And people always say, REST, yeah, that's contractless, because you can do what you want, and there is no WSDL. How do I know what's going on? But actually, there is a surprising amount of semantics present in the HTTP methods, because these three aspects, which are actually quite important for how a request makes its way into the service and how you deal with error scenarios and retries and caching. You know, a GET request, you can cache that. If you get a service and if you get a document and it looked like this, if you feel like getting it again the next 10 seconds, you can make a reasonable guess that it will still look the same if you wanted to. Idempotent also, if the document hasn't changed, then if you get it again, you're probably going to get the same result. And there's not supposed to be any side effects from getting the document. If I get the document, it's not supposed to suddenly change color while getting it. It's supposed to be a read-only operation. And you can say similar things for the other operations here. If you think them through, they really help you designing your service. If I'm storing a document, am I supposed to change it while storing it? Well, actually no, because it's supposed to be idempotent. If I put the same document again, or somebody's retrying the call, while I'm changing it in the same way, I should probably save the same content. So having a look at this, an example of what you could put on the Tradeshift API for dispatching a document. The assumption here is that we have a document that lives under /documents and a particular ID. We use keywords a lot because it's kind of an easy way to say that document over there without going into much detail on that they are unique. So a document already exists, and I want to dispatch it. And we made that a put request because the dispatch itself, so the action of sending a document to a different party, we consider the resource. Because you can look at that later and ask, how far is it? Has it been validated? Is it still on the way? Is it being delivered? Has the other party read it? That kind of information. So it's identified by a resource itself. And you send the put request over there. There's some OAuth stuff in there. In this case, we pick JSON as the content format. And the only thing you put in is, well, I'd like to send it along this connection ID. Now, the connection ID is in your Tradeshift network. You're connected to different companies. So if you want to send this document to that company, you pick the connection that you have to that company, and you put that in here, and I will send it on its way to that company. The mechanics of that is not that important. What I want to focus on is the fact that put was used here. Say that you have a client that wants to implement the send button, and it sits on a mobile phone, and the user just pressed it and nothing happens. So user presses it again, right? I want to send the document. Now, if only your client just uses the same URL, and it knows that it has just dispatched it, and I want to dispatch it again over the same dispatch, the server can figure out, well, I've already dispatched it, but it's the same dispatch ID, so I'm not going to send it again because it was already sent. And that's your idempotency here. And you get that for free, just by making that a put request and forcing your clients to think about, okay, these are the URLs I can work with, and I can just retry this safely because the server will deal with that in a way that makes sense. If it had been a post, so you post something to a URI and say, yeah, here's a document, please go and dispatch it, and then you have some query parameters that say it should go to there. The server has no way of recognizing, have I already dispatched this before? Is this the same dispatch? Would you actually like to send it twice? Because maybe you'd want that. It's very hard to reason about. In this case, by giving the dispatch itself an ID, okay, this is the operation I'm trying again, I can just skip over it. I'd like to show you a little bit on what our REST documentation looks like. I can get it to work. So we have a page online that anybody who uses Tradeshift can open. Actually, you can open it if you don't use Tradeshift on api.tradeshift.com. And it contains a list of all the resources that we have and what you can do with them. As an example, I'll find the one I was just showing about dispatching a document. Where was it? Put here. So the external part, by the way, is a historic thing where we had an external API and an internal API. A while ago, we said, well, that's not really fair. We have our internal API, and the rest of the world has to deal with the external. And we're really only using the external from now forward, but we kept the URL in there to maintain compatibility. But say for other documents, there's a particular document ID, and I want to dispatch that, and I give the dispatch an ID itself as well, so that we can recognize it. And there's some documentation here that says, well, this is the connection where the dispatch should be sent to. This is one of our resources. The rest is documented in a similar way. This might seem like a boring page. That's because it's actually generated completely from the source code. We use a framework in Java that allows us to declaratively write our resources, and which is a standard feature of Spring. But we extended that a little bit so that we could also put some documentation and other stuff in that, and that way we could scan through it and generate a page like this. Which for us has been very advantageous because we could write the documentation right in the layer where we meant to actually design that resource. The disadvantage, and I mentioned that in the beginning, it is very easy to create a new resource or to even inadvertently change one, because all it takes is just to change some Java code around. And to be completely honest, we are still trying to find the right mechanisms to deal with that. What we definitely are putting in place is a way to at least detect that we are releasing changes and having some process around that to recognize that the changes are taking place. But yeah, let's switch back. Twice. There we go. Somewhat unfortunate that Google forgets where I was. That's just not fair. Oh, we're back. Right. So about the extensibility, I want to go a little bit on how the REST API is used within Tradeshift as a final comment. So the API that you used is sitting on top of our backend right over here, and it's not just used by the small businesses to actually interact with Tradeshift. Our user interface, if you go to tradeshift.com and you create an account and you log in and everything, it talks to the exact same API for its stuff. Another way to integrate with Tradeshift is our FTP server, where you can just put your files using FTP or SFTP, and they're uploaded. It actually is not an FTP server, it's just a piece of Java code that talks to the same API and pretends to be an FTP server. And that really helps us to think about, okay, what's the API's performance characteristics? How can people log in? Where does the authorization take place? And these are things that we really only started discovering while moving to saying we are only going to use this external API ourselves. Before that, you get a couple support tickets, but it gets down prioritized because there are other customers that pay more. And really wrapping your API inside your own usage helps you to force yourself to think about the challenges in that. This is what our Java code looks like. I guess you don't want to see code. We all hate that. Any questions?
I've got a question about, in the example API documentation or the example call, you showed some IDs that were GUIDs. It looked like a GUID at least. Yeah. Do you, when people are putting documents, do you let them choose any ID format, or they can actually use anything?
They can pick any ID.
Okay, so okay.
Cool. We blow up if they use one that's already in use, or we give a nice error message that says don't use this one. Okay. But yeah, and there was a conscious decision to allow them to pick the UUID, because then they can retry the request with a predictable outcome for requests that are supposed to be.
Okay, and they can use they could use identifiers that are pertinent to their business rather than whatever you say. Well,
it has to be a GUID.
Oh, it has to be a GUID.
To the UUID format.
Oh, okay, right.
So, yeah.
Okay, thank you.
I'm just a bit curious. How common do you think this resource-oriented architecture is these days? Because there's been a move away from it. We try to add REST operations for use cases rather than exposing your data model the way you seem to do. Because it's almost like you're giving CRUD functionality to your database. Probably more complex than that, but I mean, that's something people have been trying to avoid. They're trying to hide the details of the data model. And
well, yes and no. I agree that you would not want this to map directly to your database. And you're right.
Okay, but that's not really my question. I'm just curious. Do a lot of people build REST APIs the way you do? Because that's the classic approach, isn't it? in a way. I mean, this is how REST was presented originally. And I'm wondering how common that is these days. Do you have any idea on that?
I think Google's address book service actually is very similar in that you have your contacts each sitting under their own URI if you wanted to retrieve them that way. And
maybe I can ask the audience, how many people here are building APIs this way? Quite a few.
Well, at least a couple.
I'm just curious.
Let's put together who's using SOAP still, because there must be we're using a
couple.
See, so it's all around. It's not a SOAP against REST.
No, I'm not saying. That's not. I'm just wondering this style, this kind of REST API versus other styles of REST APIs, because most people seem to be moving to REST. But.
Very interesting. I think we should head over to the other hall now. So thank you, Jan.
Thank you.